Hello dear students, this is Dr. Adil Momin from Department of Chemistry, J.A.T Art, Science and Commerce College for Women Malegaon, and today I brought you a new topic, Carbanions, an introduction. During the last lecture we have seen carbocation and its stability, formation and reactions, and today we will discuss carbanions. In this chapter we will see definition, then its structure and reactivity, characteristic features, methods of its preparation, then factors affecting its stability, and then in the final reactions and applications. So one by one we will discuss these things about carbanion. First, definition. How you can define carbanion? Any species with negatively charged carbon can be called as a carbanion. Any species in which carbon carries negative charge can be called as carbanion. So what is geometry and hybridization of this carbon which carries negative charge? The central carbon which carries negative charge has 4 pairs of electrons around it, means it contain 8 valence electrons. Okay, so 8 valence electrons, 4 pairs of electrons, means those 4 atomic orbitals around carbon will arrange themselves tetrahedrally, and the central carbon, means negatively charged carbon, will acquire sp3 hybridization, and hence geometry will become tetrahedral. The central negatively charged carbon is sp3 hybridized, and hence geometry is tetrahedral. Let us see next point. Few characteristic features about carbanion. As we know, carbon bears negative charge. It is negatively charged species, hence it will be nucleophilic, it will be sometimes basic. Okay, central carbon has 3 bonds and 1 lone pair. There are 8 electrons, 4 pairs of electrons around carbon. Out of those 4 pairs, 3 are bonding pairs. Okay, 3 bonds, and 1 is lone pair, unshared pair of electron. Then another characteristic feature, carbanion possesses 8 electrons, okay, in its valence shell. Then central carbon is sp3 hybridized as already discussed, and its geometry is tetrahedral. Let us see next slide, how carbanions can be prepared. Methods of preparations of carbanion. First method mentioned here is of course heterolytic fission. Like in carbocation, we have seen carbocation can be generated by heterolytic fission when one of the group around carbon leaves along with electron pair, bonded electron pair, leaves behind a carbocation. So in contrary, when one of the group around the carbon leaves without electron pair, leaving behind electron pair on carbon, it generate carbanion. See first example given here, a triphenylmethane, and a strong base is added into that, means that strong base picks a proton, and this bond breaks like this, means the bonded electron pair between carbon and hydrogen leaves on carbon. So there is formation of carbanion, negative charge on carbon. H plus is removed by some base. Okay, so heterolytic fission, this is a heterolytic fission of bond. Okay, next method of formation of carbanion, addition of an anion across carbon multiple bond, or any multiple bond, or maybe any neutral species. Addition of anion, negatively charged species, if added to any neutral species, then carbanion can be generated. For example given here, a carbon double bond, an alkene is there, and an attack of nucleophile is shown. If nucleophile attacks carbon-carbon double bond, then double bond opens on one of the carbon, and where it will open, nucleophile will attack on one of the carbon, and the double bond will open on other carbon, which will acquire negative charge. So this is the carbanion generated here. Okay, addition of an anion or any nucleophilic species across neutral species or carbon-carbon double bond can generate carbanion. Next method, from other anion you can generate carbanion. Like in the previous method we have seen, you can also discuss other examples. For example, a base, generally a base we are using, we have seen that in heterolytic fission, any base, for example OH minus, OH minus is a base. When this OH minus is added to any organic species in which carbon carries acidic hydrogen, for example a CH3 group attached to carbonyl group, we have seen in aldol condensation. What happen in this case? From other anion we have an anion OH minus, so you can generate here a carbon ion like this. It will pick up a proton from this carbon which carries acidic hydrogen, and it will generate a carbon ion like this, which can be stabilized by going through enol form. Okay, this C minus can be stabilized through resonance with carbonyl group. Okay, so such from other anions you can generate the carbon ion. Then factors affecting stability of carbon ion, and as we did with carbocation, we will discuss these factors affecting stability of carbon ion in some other lecture. A separate lecture I will take on this. So here just I am mentioning those factors which affects stability of carbon ion. First one is inductive effect, second one is resonance effect, then third one aromatization does affect the stability of carbon ion, then solvation also affect the stability of carbon ion. These four factors I have mentioned here. Then what are the applications or which reactions are there which involve the carbon ion formation? First one is a very famous reaction, aldol condensation, and many other condensation like Claisen ester condensation, Perkin condensation, Diekmann cyclization. Such reactions do involve the formation of carbon ion. They took place via formation of carbon ion. So aldol condensation. Then next one is FYBSc rearrangement. FYBSc rearrangement do takes place via formation of cyclopropanone, okay, alpha haloketones. So in the first step, the base attacks, base takes up a proton of alpha haloketone, and then carbon ion is generated in FYBSc rearrangement. Then that carbon ion attacks other carbon which bears a halogen group, and then cyclopropanone is produced. Such is the reaction of FYBSc rearrangement. In Cannizzaro reaction we have seen the carbon ion is formed, and then it is get converted, group is migrates to other molecule, that we have seen in Cannizzaro reaction. Then all elimination reactions which follows E1CB pathways, so those reactions also involves formation of carbon ion. The conjugate base of the molecule is produced in that case, and that is why E1CB is the name to such a mechanisms. And finally, thank you for your kind attention and listening to me. We will bring more such short videos for you. You can follow our channel of J.A.T Art, Science and Commerce College for more such videos. Thank you all of you.